This is Into Math 3rd grade, lesson 11.4. Represent rectangles with the same area and different perimeters. I can use perimeter to compare rectangles with the same area. Please gather your workbook and a pencil and turn to page 315. We will start under Step It Out Part 1, and you can pause anytime as needed. Corey plans to paint a rectangular mural with the least possible border on her back fence. The area of the mural will be 16 square feet. Part A asks us to show all possible rectangular murals that Corey could make. So it's not just asking for one, but all of the different options. And we're going to be making rectangles that have an area of 16 square feet and are rectangular in shape. So if you'd like to pause and try this on your own, you can do that, or you're welcome to follow along with me. As a reminder, 1 cube equals 1 square foot. So I'm going to start by making just the easiest one that I can think of, which would be if I fill in one of these and I go across 16 squares. So I have created a rectangle that has 1 by 16. So there's 1 square foot here and 16 across. And so that is going to be one option for the mural. The next rectangle I'm going to make is going to have 2 squares, and I'm going to create 2 all the way across until I make 16. So I have created a rectangle that has 2 feet by 8 feet, and this would be another option for the rectangular mural that has 16 square feet. Okay, and I'm going to keep moving on with the same pattern, and this time I'm going to make 3 here, 1, 2, 3. And then I'm going to continue to count by 3s until I get to 16. As I start to fill in the squares, I'm realizing that 3s do not go to 16. They stop at 15, and the next one would be 18. So this is not going to be a mural that we can use. I'll need to erase. And now I will try 4s. So I will make 1, 2, 3, 4 here and fill that in. And then I will continue making each row until I reach the number 16. When I have created a square of 16, I find that one side is 4 and the other side is 4. And again, the total is 16. Okay, so these are my 3 possible rectangular murals that Corey could make. Now I'm ready to look at part B. What is the perimeter of each rectangle? Write equations. Well, we will start with the first one that we made, and we know that each side has an opposite equal length. So if there's 1 on this side, 1 will be on this side, and 16 is here, so 16 will be on the other side here. So we can write 1 plus 16 plus 1 plus 16 to find the perimeter of our first rectangle. If you would like to pause and solve this addition equation, you may do so. And when you come back, you will find the answer will be 34. Okay, let's take a look at our next rectangle. We have 2 squares by 8 squares, and we know that 2 would be on this side and 8 would be on this side. So we can write 2 plus 8 plus 2 plus 8 equals, and if you would like to pause and solve this equation, you can do so. And when you come back, you will find that the perimeter is 20 feet. Okay, let's take a look at our third option here, and we have 4 by 4 by 4 by 4. So we have 4 4s. So we will write the equation 4 plus 4 plus 4 plus 4 equals, and again, if you'd like to pause and solve this equation, you can. And when you come back, you will find the answer is 16. Now let's look at part C. The least perimeter is, so we need to look at our solutions. We had 34, 20, and 16. Which is the least? The smallest number is that 16, so we can write that in here, 16 feet. And now we can look at part D. To have the least possible border, Corey should make a rectangle with the side lengths of. Now, which one was the 16 feet perimeter? That's right, it was the 4 by 4 by 4 by 4. So we can answer the rectangle with the side lengths of 4 feet. Let's take a look at the next page, page 316, Step It Out Part 2. Mel plans to build a rectangular play yard for his puppies. The area of the play yard must be 12 square meters. Part A asks us to draw all rectangles that can represent the play yard. So if you would like to pause and try this part on your own, you may do so. Just like before, 1 cube equals 1 square meter. As always, you are welcome to follow along with me. Okay, so I will start again by making the easiest one that I know how to find that area of 12 meters. And that would be filling in 1 cube, 1 meter, and completing until there were 12 across. And now I have created a rectangle that is 1 by 12 squares, 1 meter and 12 meters across. Okay, now I'm going to do the same thing that I did before, and I'm now going to look at creating a rectangle that has 2, and I'm going to count by 2s until I get to 12. So I know that's 2, 4, 6, 8, 10, 12. And I will create a rectangle that has 2 meters up and down and 6 meters across. Okay, now I will try using 3s. I will draw 1, 2, 3 squares here, and I will count by 3s until I get to the number 12. 3, 6, 9, 12, and then I will fill them in. So I have created a square that is 3 meters across and 4 meters on the other side. I know that I have found all 3 combinations and all the rectangles that can represent the 12 square metered play yard. And the reason I know this is because I know the combinations of how to make 12 using multiplication. 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. I have drawn 3 of these. But when I look at the next factor of 12, I notice that 4 times 3 is the same as 3 times 4. And 6 times 2 is the same as 2 times 6. And 12 times 1 is the same as 1 times 12. This is the commutative property that we have studied in multiplication, that order does not matter. I will still get the same product, which is 12. Let's take a look at part B. What is the perimeter of each play yard? Write equations. If you would like to pause and try this part on your own, you may do so, or you can choose to follow along with me. I will start with the first rectangle I created, and in knowing that the opposite sides have the same equal length, I will put a 1 here and a 12 here. So I can write 1 plus 12 plus 1 plus 12 to find the perimeter of the first rectangle. If you would like to compute this on your own, you may pause to do so. And when you come back, you will find the answer is 26 meters. Now let's take a look at the second rectangle that was made. Again, each side I know that's missing the number I'm going to write in. And so then I can write the equation or create the equation for the perimeter. 2 plus 6 plus 2 plus 6 for this rectangle. And if you would like to pause to compute this addition equation, you can. And when you come back, you will find the answer is 16 meters. Now let's take a look at the last rectangle that we made. Again, knowing the other sides, we write those in, and then we can create our perimeter equation with addition by writing all the signs added to each other. And if you would like to pause to compute this addition equation, you can do so. And when you come back, you will find the answer is 14 meters. Now let's look at part C. The play yard that is blank meters long and blank meters wide will have the greatest perimeter. So of all the sums that we created, which is the greatest? It should be this one here with 24 meters. That's the biggest, greatest perimeter. So that was a play yard that was 1 meter long and 12 meters wide. If you would like to go back and rewatch this video, you can do so and pause along the way at any time as needed.